this is the last day hard Leetcode question. So this is a 2-3-2-2 minimum score after removal of on a tree. So in this question you are given an undirected connected tree with the n nodes leveled from 0 to n minus 1 and n minus 1 edges, and you have given a value as well, like in the nums array you have given the value of ith node, and you are given a 2D integer array edges that is considered to be the relation between the edges, like which is which node is connected to another node. So it is the edge, and you have to remove two distinct edges from the tree. You have to remove two edges like this one or this one you remove, then you will left with the three connected component. And for the removed edges you have to do this following things, like you have to XOR all the value of the nodes for each of the three component respectively. Like you will left with three components, so you have to XOR all the values of the nodes in the component for all three components, and you have to find out which is the largest and which is the smallest, and find out the difference of those, and you have to minimize the score possible. So let's go to the logic part. So in the question we have given a tree like this. Let me consider the example number 1. So example number 1 is this, and their value is 5, 1, 5, 4 and 11. So we have given a 2D array edges that will be considered that this node is connected to this node, and another array that is given is nums, which is none other than the value of the node, each node. So it is the value of each node given into the nums array. And what we have to do here is that we have to partition this whole tree into three parts. Like we can partition into this, this and this. So we have to partition into three connected component, not disconnected. Like if I just consider these three parts, then we can't do this part because this will not be connected. To connect these both we have to consider these as well. So we can do another thing is that we can consider the first part as this and second part as this. Okay, let me check, like first part as this, second part as this, and third part as this. So in this way we can partition three component, and we have to find out the minimum difference between the largest and the smallest. What the smallest and largest? So we have to find out the XOR value of all the component. Every component, we have this component, this component, this component. So we have to find out the XOR in the all component with their value, and we will be having three value of XOR. One will be the largest one, and one will be the smallest, and one will be in the mid of this. So we have to minimize the value of largest and the smallest. So for that what we will do is just will you check all the combinations between the largest XOR and the smallest XOR value of the XOR value of a component. So we'll just check that if we have this, let me consider another tree like this and this and this and this. So if we have to choose this tree, this is the tree, and we have to uh, give the three components. We have to partition into three connected components. If we consider the first component as this, second component as this, and third component as this. So we will find all the we'll find the XOR of all the values in the component with their values, and we'll find out which is the largest one and which is the smallest one, and we'll check that it is minimum or not. For like this is the first partition we have done. The second thing we can consider is that this is this is our first part, this is our second part, and this is our third part. So this is another combination of three component. So in this as well, we will choose the largest and the smallest, and again we will check that which is the minimum, and again update the minimum value. Again we can do another thing is that we'll consider this as the first part, and this is as the second part, and this is the third part. So in this way, we'll just choose all the combination of three component, and just update the minimum value of the largest and the smallest jar that we are getting from uh, jarring between all the value of the nodes in a component. So for that, what we can do is that we'll just traverse, like if we consider the same tree as this is the our tree. So finding out all the combinations of the component in like three components, we have to divide. So what we'll do, just we'll traverse the whole tree with using DFS, and we'll just backtrack to the first like previous parent, and we'll choose that subtree only. And in that subtree we again do another DFS, and that will choose another subtree into that, and we'll get this jar value and this jar value. And finding out the remaining jar value, what we can do is, just let me show you. Let's see, if we have a total jar as 10. Let me see, do it like this. Let's say this is your total jar value, okay? And the first subtree that is like your, let's consider this only. If it is your tree, and your first like subtree is this, and second subtree is this, and the remaining portion is this, then let's consider the whole XOR is as this. Let me give the value 5, 6, 7, 8, 9, 10. Then we'll left with all the jar value like 7, 8, 9, and 10. And if we consider the this subtree only, then we will left with the 7 XOR, 8 XOR. If we consider this component only, after like removing this subtree, then we're left with 7 and 8. And if we consider this only, like 8 and 9 and 10, or if this consider, then for finding out the third remaining portion, what we'll do is just we'll do total XOR first, XOR second. And what we'll do here, what we get here is that after XORing again into the total, when we XOR first into total, the first which we are having into the total will be removed. Like when we do 4 XOR 4, then it will give you 0, and a 0 XOR anything will give you anything. That is the XOR value. So the first is will be removed from total, and second will be removed from total, then we will left with the remaining portion. So what we'll do, we'll just traverse using a DFS search, DFS, and after backtracking we'll consider every subtree, and into that subtree another DFS will be happening, and there as well we will just backtrack, and we'll consider all the subtree of the subtree, and then we'll get with the three connected component, and that we have to consider. and their XOR value will be also there. So for checking out that which is the largest one, what we'll do is just will having first, second, and third XOR value. So we have to find out which is the largest one and which is the minimum one. So we'll find the minimum as well, first, second, and third, and we'll have another variable that is answer, and that will be largest minus minimum of minimum, like minimum of this comma answer, and that will be your answer. And in this way we'll do this. So if I have to show you the code, let me do that, how code will look like. So let me go through my codes. So in this question what we are doing is just like initializing n with the nums size, like how many nodes we have, and we are initializing adjacency, adjacency list named as graph, and we'll just pushing the relationship between the nodes. And after that we just find out the total XOR, as we have mentioned that we have to do total XOR first, XOR second, that will give you the remaining one. For that we are just doing all the value XOR. We are finding out the total XOR with all the value in the graph. And after that we just do a DFS on the 0th node, that is the root node. And what DFS is doing is that just finding out all the neighbors which is not the parent, and we are just finding the neighbors and finding out just like give me all the jars of your subtree, and if it is giving your jar all the subtree, and finding all the subtree jar and then give it to you, like it's just giving you all the XOR value in that subtree. If it is considered to be zeroth node, then it is considered to be whole tree XOR value will be there. And after that we are just doing a backtrack. We'll just go to that previous parent and we'll just do uh, consider this subtree, and find out that in this subtree what is the XOR value, and in that as well we are doing another DFS that will give you the second removal of the edge. You have to remove two edges. So the first removal is happening here. We are just considering the subtree like here, and another we are doing is that in that subtree we considering another subtree, and that is the second removal. And DFS here is doing the same thing, like in that uh, subtree of subtree, in that we are finding out the XOR value of that subtree of subtree, and we are checking that the parent is equals to ancestor or not. And there we are just updating the minimum value of the whole, like here we are just initialized a function to find out the maximum of all those XOR value and minimum of all those XOR value and what is their difference, and we are just updating a result with the minimum value of those. So that is how we are doing. So that is all about the code. So thank you for watching this video.